Hello everyone and welcome. We're going to look at our next activity together, which is on more visual patterns and also bringing in those explicit formulas that we've been looking at. So this first one says to drag the slider to explore this pattern. So here's figure 1. We have 6 little boxes here. Figure 2, what's happening with the amount of boxes. Compare that to figure 3 and then figure 4. So how do you see this pattern growing? Just doing a little warm-up response. You can pause the video if you need to. And then when you're all set, push ahead to slide 2. Here is the pattern from the previous screen. How many tiles will there be in figure 7? So let's take a look at how many tiles we have in these figures. We have 6, and then we're going to 12, 24, and then 48. So, if it was arithmetic, we would be adding 6, but 12 plus 6 is 18, so that would not work. So this must be multiplication. We are multiplying by 2 to get the next figure amount. We can do this to get figure 7. We could just make a little table, have figure, and then number of tiles. So for figure 5, 48 times 2, let's see, where's my calculator? Gets us 96. For figure 6, 96 times 2 is 192. And then finally, figure 7 is 192 times 2, which gets us 384. So this is doing it not using a formula, but just doubling that amount each time. We can type it in and hit try it. And it's filling in those tiles for us. Beautiful. So how could we determine the number of tiles in figure 15? Well, of course we could just keep multiplying until we get to figure 15. We'll have to do like 7 or 8 more multiplication to get to 15. So a quicker way to do that would be to use our explicit formula for a geometric sequence, which would be starting with this value of 6 and then multiplying by 2 until we get to figure 15. So let's take a look at working through that on slide 3. So Zoe's strategy for determining the number of tiles in figure 15 is as followed. 6 times 2 to the 15th. Now Zoe did do something well here, but there is a mistake here as well. So what do we think? We can see that Zoe identified the common ratio of 2 correctly, which is great. She also represented, or I can say, they also represented figures 1 through 4 with the correct expression. But something that we're going to talk about in this lesson that we have to be careful about is this is starting with figure 1. So typically when we just put that number in the exponent, we would have started with figure 0. So we don't actually want to multiply it 15 times to get to the 15th figure. We're going to multiply it 14 times because we're already at figure 1. So to get to figure 15, we will only be multiplying by 2 14 times. not 15. If we multiplied this 15 times, we would end up at figure 16. So we're going to talk about ways to figure out how we can write our explicit formula depending on if we have figure 1 or figure 0. So let's go to slide 4. You can hit share with class and then move to slide 4. Amar and Maria want to rewrite an explicit formula for the number of tiles n. So Amar writes, we're starting at 6, and then I'm multiplying by 2, and then I'm just going to do n minus 1. Now, what this does is we're not just, if we wanted to find the 15th, we only want to multiply it 14 times. So 15 minus 1 is 14. So that would get us the correct formula for this geometric sequence. So that is correct. That looks great. Maria, what Maria did is notice that Maria's formula starts with a 3. So Maria worked backwards to figure out figure 0. So instead of multiplying by 2, Maria divided by 2 to get 3 tiles and worked backwards. That would be the amount for figure 0. So Maria starts with 3 and we're multiplying it by 2 to the nth, which, yes, now to find the 15th version, it would be 3 times 2 to the 15th. So both of these actually work. So Amir's is focused on starting with figure 1. Maria's is focused on starting with figure 0. And what I'll show you in the calculator is if we have 6 times 2 to the 15 minus 1, we can compare that to 3 times 2 to the 15th. And notice they're going to be the same value. Both of these formulas are going to give us that same amount of tiles that will be in the 15th figure. And we could do this for any figure. Figure 8, change that n value to 8, and they'll be the same, 768. So it's always going to depend on if, when you're writing the equation, thinking about is it figure 1 or is it figure 0? And then it's going to kind of be your choice. There might be one that clicks or feels better in your brain than the other one, so you will have the option to decide which one works best for you. Slide 5 when you're ready. It says, here's a new pattern. How many tiles will there be in figure 4 and in figure 15? So we have 5, 8, and then 11. So we can see that this is going up using addition. We are adding 3 each time. So of course, for figure 4, 11 plus 3 is 14. To get to the 15th figure, we could add 3 many more times. Let's practice writing a formula. So our first tile, our first figure is 5. We are adding 3, but we're not just going to put an n here because we're starting with figure 1. So we don't want to add 3 15 times. We just want to add 3 14 times. So we put our n minus 1. So we have 5 plus 3 to the, plug in that 15 for n. 3 times 14. 3 times 14 is 42. So we have 5 plus 42, which equals 47. Oh, we have to check our work for this one. And then it'll let us type this in here for 47. Beautiful. If we wanted to start with figure 0, we could. We'd work backwards. So instead of adding 3, we're going to subtract 3 to get 2. So our formula would be 2 plus 3 times n. N is still 15. 3 times 15 is 45. 45 plus 2 is 47. So whether we start with figure 0 or figure 1, as long as we write the equation correctly, we're good. Beautiful. Get everything you need here and then push to slide 6. Compare and connect. Here's Omari and Ivory's responses for figure 15. And here's our two different equations. So as Omari did our first method, which was starting with 5 tiles, starting with figure 1. So because of that, they multiplied by 14, which is our n minus 1, versus for figure 0, and there's 2 tiles, and then they multiply by 15. So we see where those numbers have come from, and we worked through those explicit formulas in the last slide. But there's that information there, and then you can push to slide 7. Here are Omari and Ivory's responses for figure 15. Write an explicit formula for n tiles. So there's 2 that we could do here. We could do 5 plus 3 times n minus 1. And that will work. Or we could do Ivory's, which would be 2 plus 3 times n. So because we start with figure 0, we can just write n. If we start with figure 1, we want to do n minus 1. Beautiful. Figure 8. Let's look at the sequence without a visual pattern. Here are the first 5 terms. Write an explicit expression for term n. So let's do it starting with term 1 first. So we start with 12. These numbers are jumping up pretty quickly. So we have a multiplier. 12 times 3 is 36. 36 times 3 is 108, and so forth. So we are multiplying by a constant ratio of 3. Because we started with figure 1, we want to make sure we write this as n minus 1. Versus if we worked backwards, we could divide by 3 to get figure 0. 12 divided by 3 is 4. So we'd start with 4 and multiply it by 3 to the n. Either way, both of these are correct. Write whichever one you want and works best for you. We just want you to feel comfortable working with either type, whether it's starting with figure 0 or with figure 1. Beautiful. Let's look at slide 9. On slide 9, you are going to make your own challenge. You're going to decide if it's arithmetic or geometric. Enter a first term and a constant difference. Make your sequence. And then you're going to hit next. And then you're going to write an explicit expression here. So we start with 7. We're subtracting 2 times n minus 1. Check my work. Perfect. And then you can submit your challenge. Once yours is submitted, then you will do someone's challenge from one of your classmates. So make sure to submit there. Slide 10, describe one strategy for writing an explicit expression for term n of a sequence. You can use this example if you want, but you're just describing what the strategy is for creating that formula. Slide 11, write an explicit expression for the number of tiles here. Notice if it's figure 1 or figure 0, and which one, however you choose to write your equation based on that is your choice. And then finally, the little reflection on slide 12. I know these can be a little tricky sometimes, so again, as always, reach out to me if you need extra support. I'm on your team. I'm here for y'all. Great. Great work today, friends. Take care, and I'll see you all next time. Bye.